Hello dear friends, you all welcome back to Physics Corner. In the last lecture of classical mechanics, we have discussed some practice examples of a Newtonian mechanics application. Now in this video, we are going to discuss Lagrangian Dynamics. अब देखिए, यहाँ पे सवाल ये उठता है कि हमारे पास तो न्यूटन मैकेनिक्स था, फिर why we need this Lagrangian Dynamics? देखिए भाई, एडवांस ज़माना है, ज़माना बदलते रहता है. पहले हमारे पास डब्बा फ़ोन रहता था, कीपैड वाला. ज़माना बदल गया, स्मार्टफोन आ गया, एडवांस. ओके, तो देखिए अब ये एडवांस क्यों हो गया? तो डब्बे फ़ोन में भाई कुछ ड्रॉबैक्स थे. वीडियो कॉल नहीं कर सकते थे भाई डब्बे फ़ोन में. ओके, उतना था ही, ऐसे ही नहीं होता था. तो न्यूटनियन मैकेनिक्स में ऐसे कुछ ड्रॉबैक्स है, उसकी वजह से ही Lagrangian Dynamics क्या हो गया? प्रोड्यूस. नाउ सी which are the drawbacks due to which Lagrangian introduced his own dynamics. Now see the first drawbacks of Newtonian mechanics. A body in a motion required separate set of equations for translational and rotational motion. Oh. Now see, I am moving in a straight line. That was translational motion. If I am rotating in this way, this is was rotational motion. Oh, for a translational motion and for a rotational motion required different sets of equation. Now see how. In a translational motion, position is defined as a r. Okay, r represents my position. Now, but in a rotational motion, my angle, at what angle I am rotating, that angle defines my position. Okay, and in the translational motion, velocity is defined as a v, and in rotational motion, angular velocity, that is omega. Okay, and in translational motion, a is defined as acceleration, but in rotational motion, alpha is defined as my angular acceleration. In terms of translational motion, force is defined as F equals to ma, but in a rotational motion, in place of force you have to write torque. Okay, now torque equals to moment of inertia I into acceleration alpha. Okay, now see, this is the first kinematic equation, v equals to u plus at, but in the rotational motion, omega equals to omega naught plus alpha t. But we need a more generalized system. तो देखिए क्या हो गया, ट्रांसलेशनल के लिए अलग जो भी सेट था इक्वेशन का वो अलग बन गया, और रोटेशनल के लिए भी क्या बन गया, अलग. नो डिफिकल्ट हो जाएगा ना. फिर रोटेशनल के लिए ये सोचो, फिर ट्रांसलेशन के आर भी ओमेगा, फिर उसके लिए ओमेगा थीटा अल्फा, कंफ्यूज. सो we need a more generalized system. Now see the second drawback. Newtonian mechanics is difficult to solve the system of higher degree of freedom. अब देखिए, डिग्री ऑफ फ्रीडम इसको हम इंट्रोड्यूस करेंगे बाद में. तो डिग्री ऑफ फ्रीडम शॉर्ट में बताता हूँ. द नंबर ऑफ generalized coordinates which are required to define the motion of system, that is nothing but the degree of freedom. But when the degree of freedom is higher, then Newtonian mechanics is difficult to solve that system. Okay, now see the third. We need a generalized mechanism which can be applicable to any degree of freedom. Okay, now see the last drawbacks, that is constraint force are not included in Newtonian mechanics. अब constraint भी हम इसके आगे definition सीखेंगे. Okay, these are the three drawbacks. Last one is the constraint force are not included in a Newtonian mechanics. Okay, these are the drawbacks due to which Lagrangian introduced his own dynamics, that is Lagrangian dynamics. Now see, we will discuss now some important definitions like degree of freedom, constraint, and what is the generalized coordinate, generalized velocity. See, Now let us discuss some important definitions. Now see the first important definition, that is the generalized coordinates. Now see the definition. A set of independent coordinates required to describe a motion of a system are called as a generalized coordinate. Now see, I am in a 3 dimension. To define my position, one may require 3 coordinates, that is x, y and z. Okay, to define my position, one may require 3 coordinates. In generalize, you can say q1, q2, q3. If there is a body, that body required 5 coordinates to define its motion, then that 5 coordinates are q1, q2, q3, q4 and q5. Okay, if there is a body which required n number of coordinates to define its motion, then q1, q2, q3 up to qn, these are the generalized coordinates to define the system. Okay, this is nothing but the definition for generalized coordinate. A set of independent coordinates are required to define the motion of that system is nothing but the generalized coordinate. Now see what is the generalized velocity. The time derivative of generalized coordinates. Simple. Velocity is nothing but what? Position per unit time. Here is position defines this generalized coordinate. Then the time derivative of generalized coordinates are called as a generalized velocity. See, q1 dot. Dot defines derivative with respect to t. Dot defines, see, dot defines derivative with respect to t, and this bar defines derivative with respect to position. Okay, dot derivative with respect to time, and this slash defines derivative with respect to position. Here is a dot. Then derivative of a q1 with respect to t, that is nothing but the time derivative of position, generalized coordinates, that is nothing but the generalized velocity. Simple definition. Now see the third one, constraint. A physical restriction imposed on the motion of a system which cannot be broken during its motion. Now see, constraint means restriction. Now I am restricted in one room. जब तक वीडियो कंप्लीट नहीं होगा तब तक मैं यहाँ पे restrict रहूँगा. This is the my constraint. Okay, a fan is rotating in the around this axis, that is the constraint. Okay, constraints means what? Restriction. If I take a simple plane, then I put a pen, that pen is restricted to move in this only surface. The pen is restricted. Okay, if I take, then pen is restricted to move in a 3 dimension, but now only surface, now 3 dimensional, like this. Okay, if we put some restrictions on a body to move only in that circumference, that is nothing but the constraint. Now these are the 3 important definitions. Now next we will discuss the degree of freedom. What is the degree of freedom and their example. See, now see the important, the degree of freedom. What is the definition of degree of freedom? The number of independent variables are required to describe the motion of system is called as a degree of freedom. The number of independent variables required to describe the motion of a system. Now I am in a 3 dimensional and I required 3 variables x, y and z to define or to describe my motion, and that 3 coordinates or that 3 variables are nothing but the degree of freedom. So what is the degree of freedom mean? 3, because there are the 3 coordinates which are describing my motion. ओके, इतना सिंपल था. अब देखिए कुछ इसके नोट्स हैं. फ्री फ्रॉम मेजरमेंट्स. नाउ सी, आई एम and this is the plane which is moving in a 3 dimension. Okay, this plane also required 3 coordinates x, y and z. Okay, that is the plane has a 3 degree of freedom because plane is required to describe the 3 variables and for me also I required a 3 variables x and y z. That's why the pen and me have a same degree of freedom, but but my mass is greater than pen and pen length is small than me. That's why there is no required of a measurement. Okay, the degree of freedom is free from a measurement. Okay, there is no requirement for the measurement of a degree of freedom, and time never be included. सुबह भी मैं यहाँ पे आया, दोपहर में भी आया और शाम को भी आया, तो डिग्री ऑफ फ्रीडम मेरा चेंज हो क्या? नहीं. टाइम नेवर बी इंक्लूडेड इन द पार्ट ऑफ डिग्री ऑफ फ्रीडम. नाउ सी द थर्ड नोट. एवरी कंस्ट्रेंट रिड्यूस डिग्री ऑफ फ्रीडम. एवरी कंस्ट्रेंट रिड्यूस डिग्री ऑफ फ्रीडम. तो देखिए ये नोट याद में रखना, इसको हम एग्जाम्पल लेते हुए देखेंगे. अब देखिए इसके कुछ एग्जाम्पल्स देखें. एग्जाम्पल फर्स्ट. नाउ सी, I have considered a three-dimensional space x, y, z. Okay, three-dimensional. Okay, and here is a mass m. How much degree of freedom is required, or how much variables are required to define this mass in a 3D? Only 3, because it varies x, y and z. That is, the degree of freedom is nothing but how many? 3. Okay, no problem. Now see the example second. Okay, I am considering three-dimensional space which requires x, y, z. Okay, now see, I am taking a system mass m1, mass m2. ओहो, क्या कर दिया मैंने अब? Something mass m1 mass here and m2 mass here. And what is this? This is the constraint. What is this? This is the constraint. Now see, if there is no constraint in between m1 and m2, m1 required 3 variables to define its system, and m2 requires also 3 variables. Now see, there is a constraint. Now see, total number of variables is how many? 6, because m1 required 3 and m2 required 3. Therefore total number of variables is how many? Number of constraint is how many? Constraint. Number of constraint is how many? This is one constraint, 1. Therefore degree of freedom is nothing but 6 minus 1. That is the number of variables minus number of constraint, 5. Degree of freedom is how many? 5. Now see, note किया था, every constraint reduce a degree of freedom. If there is absence of constraint, अगर यहाँ पे ये constraint नहीं रहता था तो degree of freedom कितना रहता था? 6. m1 3, m2 3. But here is a one constraint, and that constraint reduce the degree of freedom by 1. Okay, this constraint reduced the degree of freedom by 1 and degree of freedom comes 5. अब देखिए, इसके लिए हम एक शॉर्ट ट्रिक है हमारे पास. शॉर्ट ट्रिक, सी, f equals to d into n minus c, where f is a degree of freedom and d be the dimension and n be the particles, how many particles, and c be the constraint. C be the what? Constraint. Now see, using this formula you can find the degree of freedom for this and for this. See, for this, देखिए शॉर्ट ट्रिक बड़ी काम की है, आसान से आंसर निकल के आएगा, कोई ज़्यादा दिमाग लगाने की ज़रूरत भी नहीं रहेगी. तो देखिए आप, f equals to d into n minus c. Apply this trick for this example. Now see, f equals to, d means dimension. In which dimension this particle m? 3-dimensional. Oh, 3-dimensional. Now see, n means the number of particles. How many number of particles are there? Only 1. Okay, into 1. And is there any constraint to this particle? No, there is no constraint. Constraint, it was 0. Therefore, F equals to 3 into 1, 3. Degree of freedom is how many? 3. You can see degree of freedom is 3. Apply this trick to this example. This is the example number first, and this will be the example number 2. Okay, F equals to D(n) minus C. Okay, F means degree of freedom. Now see, dimension is 3-dimensional. Number of particles is how many? M1 and M2. There are the 2 particles. Okay, and constraint is how many? 1 constraint. 4 minus 1. 3 into 2, 6 minus 1 equals to how many? 5. ओहो, काम कर रही है भाई ट्रिक. अब देखिए और एग्जाम्पल देखेंगे भाई. देखिए एग्जाम्पल नंबर 3. ओके, this is the 2-dimension, only x and y. Okay, I am considering the system now. This is M1, M2, M3, and 1, 2, 3 constraints. 1, 2 and 3 constraint. Okay, then what is the, देखिए ऐसा सवाल स्टेट लेवल के जो आपके पेपर रह जाएंगे, केरला सेट, गुजरात सेट, महाराष्ट्र सेट, तो ऐसे सवाल पूछ सकते हैं. तो देखिए, अप्लाई द शॉर्ट ट्री. F equals to Dn minus C. Okay, dimension is how many? 2 dimension. Number of particles is how many? 1, 2 and 3. Okay, no problem. Constraint is how many? 1, 2 and 3. Okay, 3 into 2, 6 minus 3 equals to 3. This is nothing but the degree of freedom for this system. इतना simple था भाई. Just apply the trick. Now see, again we will take some problems. Easy. Struggle. Every day you have to practice to crack the exam. It's not a one-day game. Okay? Now see example number 4. Oh, now see, I am considering a 3-dimensional space, x, y and z. Oh, space is a 3-dimensional. Now I am considering a system M1, M2, M3, M4. These are the constraints. Constraint is how many? 1, 2, 3, 4, and dimension is 3. Number of particles 4. Then apply your short trick. F equals to Dn minus C. What is the dimension? 3-dimensional. Oh, 3. Number of particles 4. Constraint 4. 3 into 4, 12. Minus 4. Then how many degree of freedom? 8. Aha. Short trick. है ध्यान में? तो आपको ऐसे सवाल लगाना है. अब देखिए, सिंपल पेंडुलम का एग्जांपल लेंगे. This is the mass m moving like this, and this is the variable theta. Now see, to describe this motion of that m particle, you required only one variable, that is nothing but the theta. Okay, to describe the motion of a simple pendulum, you required only one variable, that is theta. Therefore, degree of freedom is how many? 1. Okay, अब देखिए और एक एग्जांपल देखेंगे. अब देखिए, here is also pendulum, but here is a spring. Okay, now see, अब देखिए ये जो स्प्रिंग रहेगा, ये ऊपर नीचे, that means here is a one variable, and again the theta. That means to describe the motion of this body, you required 2 variables. That's why the degree of freedom for this 2. Oh, now see the another examples. See the some more examples also. Double pendulum. Find out the degree of freedom for the double pendulum. Oh, easy. theta 1, mass m1 moving like this. Then again the pendulum, double pendulum, theta 2, mass m2 moving like this. Now see, to describe the double pendulum system, you need only two variables. That is the first one theta 1 for m1 and theta 2 for m2. Therefore, degree of freedom is how many? 2. Simple सवाल था भाई. Now see, we are considering a cylinder. Okay, and the particle is moving on this cylinder. Okay, and we also consider the bowl. Okay, there is a particle inside this. Now see, this particle is moving on the surface of cylinder and on the inner surface of that bowl. If I consider this pen is moving on the surface of the whiteboard. Then the degree of freedom is how many? 2. Because if we are considering a surface that requires only two variables, x and y. Therefore, if a particle is moving on any surface, degree of freedom, sir, 2. If a particle is moving on any surface, then degree of freedom is how many? 2. Any particle is moving on any surface, degree of freedom 2. नींद में भी आना चाहिए भाई. अब देखिए, if I consider different types of shape of wires, okay, if a particle is moving on this wire, then what is the degree of freedom for this? Degree of freedom for this is 1. Because if I take a particle that is moving, if I consider this is a wire, if this is moving on this wire, only just one variable is required to define the motion of that particle on this wire. That's why degree of freedom is 1. If a particle is moving on any shape of wire, then what will be the degree of freedom? 1. Okay, these are the examples for the degree of freedom. Now we will discuss the types of constraint. Okay, तो जो मैंने आपको पहले ही पढ़ाया था restrictions. Okay, तो इसके लिए हम देखिए types देखेंगे. Now see the different types of constraint. First one is a celeronomic versus rheonomic. Now see, the remark for celeronomic is independent of time and remark for rheonomic is dependent of time. तो देखिए एग्जाम्पल लेंगे. अब देखिए यहाँ पे सिंपल पेंडुलम हम एग्जाम्पल लिया. अब जो यहाँ पर जो ये लेंथ है, ओके, जो भी स्ट्रिंग रहेंगी उसकी लेंथ है वो क्या है? कांस्टेंट थ्रू आउट अ टाइम. अगर आपने सुबह भी गिना, शाम में भी गया, दोपहर में भी गया, तो लेंथ कैसी रहेंगी? कांस्टेंट. दैट मीन्स विच इज द इंडिपेंडेंट ऑफ टाइम. दिस टाइप ऑफ constraint is nothing but the celeronomic constraint in which the independent of time is considered. Now see, in the rheonomic what happens? Depends on a time. Now see, here is a considering we are pendulum, okay, moving like this, and here is also spring, okay, and that the length of that spring depends on a time. Okay, spread, expansion, compression, expansion, compression, expansion, compression. Okay, that expansion and compression of that spring depends on a time. Length is not constant at any instant of time. Here length is constant at any instant of time. That's why this is the independent of time and it comes under the celeronomic constraint. and here the length is not constant, that because that the expansion and compression is depends on a time. That's why this comes under the rheonomic constant. Now see third one, the holonomic. Does not lose the contact. If I consider a sphere, okay, if I consider a sphere and there is a particle on that sphere, okay, now see, if I consider a sphere, the radius of that sphere is a capital R, okay. Now if I consider a particle constrained to move on that sphere, and that radius of that particle is smaller, and that will be equals to capital R, because that particle is constrained to move on that only sphere, okay, because that particle does not losing the contact, he is continuously moving on that sphere, okay. This type of constant is now called as holonomic. Now see how the non-holonomic. Again I consider the sphere, okay, but I consider a particle which is inside that sphere, okay, which is inside that sphere, okay. Now see, the position of that particle is less than the radius of that sphere, okay. That means that particle lose the contact, okay. इस केस में क्या था, घूम रहा था कंटिन्यूसली, कांटेक्ट नहीं लूज किया था. इसमें क्या कर दिया उसने, अंदर चला है, कांटेक्ट क्या कर दिया, लूज. कांटेक्ट क्या हो गया, लूज. नाउ सी, इन केस दैट पोजीशन ऑफ दैट पार्टिकल इज लेस देन द रेडियस, बट नाउ if I consider a particle which is constrained to move at a some distance from the sphere, okay, यहाँ पे ये घूम रहा है, ये घूम रहा है भाई, ये घूम रहा है, okay, then the position of that particle is defined by the small r, and which is the greater than this radius of that sphere, okay. यहाँ पे दो केस हमने देखा. तो where the particle lose the contact, that comes under the non-holonomic, and here the particle does not lose the contact of the sphere, which is continuously moving on the surface of the sphere. Here the particle is continuously moving on the surface of the sphere, but here the particle lose the contacts. तो देखिए और एक इसका एग्जांपल देख सकते हैं हम. If we consider a water bottle, there are the, if we consider a water bottle, okay, there are the large number of water molecules, water particles are there. Now see, if the particles is attached to the sphere, okay, sorry, to the bottle, if the particle is attached to the surface of the bottle, then that is the particle does not lose the contact, that type of constant is not holonomic. But if the particle is in the center, which is does not in contact with the any surface of that bottle, then that type of constant is not holonomic constraint, okay. और भी इस कंस्टेंट के कुछ टाइप्स है, जैसे कि कंजर्वेटिव और नॉन कंजर्वेटिव, तो ये आप देख लेना. अब देखिए एक छोटा सा पार्ट रह गया हमारा, हाउ टू फाइंड द डिग्री ऑफ फ्रीडम फॉर अ रिजिड बॉडी. ओहो, इसके लिए तो भाई हमारे पास शॉर्ट ट्रिक ही है, ओके. रिजिड बॉडी, रिजिड बॉडी. नाउ व्हाट इज द रिजिड बॉडी? It contains n particles. It contains n particles which are connected by light rigid rod, okay. जैसे कि if I consider the two particles here and here, these two particles are connected by this light rigid rod. So this type of system is called as rigid. What is rigid body? Now see how to find the rigid body, degree of freedom for a rigid body. Bhai, shortcut re bhai. What is the shortcut for degree of freedom for rigid body? D into D plus 1 by 2. Oh, sir, short trick. Now see, here D is a dimension. What is dimension. Okay, if you have a rigid body system, okay, that is in a 3-dimensional, just put 3 here, 3 into 3 plus 1 by 2, 3 plus 1 4, 4 into 3 12, 12 by 2 6. This is the degree of freedom for a rigid body in a 3-dimensional. Okay, second example, put a now in a 2-dimension. Oh, 2-dimension, 2 plus 1 by 2. This is 3, 3 into 2 6, 6 by 2 3. Oh, degree of freedom for a rigid body in a 2-dimension is 3 and for a 3-dimension is 6. तो देखिए ये शॉर्ट ट्रिक आपको ध्यान में रखना है. ओके, तो देखिए इतना कुछ हमने इस वीडियो में पढ़ लिया. पहले तो हमने देखा था कि लैग्रेंजियन डायनामिक्स इंट्रोड्यूस किया, इसके बाद फिर न्यूटोनियंस के ड्रॉबैक्स देखे. ओके, फिर उसके बाद हमने कुछ इंपॉर्टेंट डेफिनेशंस देखे, जनरलाइज कोऑर्डिनेट, जनरलाइज वेलोसिटी, व्हाट इज द कंस्ट्रेंट. आफ्टर दैट वी हैव डिस्कस द डिग्री ऑफ फ्रीडम एंड द एग्जांपल्स and then the types of constraint, and lastly the rigid body. Okay, in the next video of classical mechanics we will discuss the D'Alembert principle, and after that we will derive the Lagrangian equation. Okay, अगर आपको वीडियो अच्छी लगी तो सब्सक्राइब ज़रूर करना and hit the bell icon for more updates.